Good day friends, welcome back to Smart Booker. In today's video, we are going to be solving another problem. This question is similar to one of the problems we solved with 2-point charges located on the vertices of a triangle. But this one, instead of finding the force, right, on the point P, this one we are looking for the electric field. So it's quite similar, but what we are actually looking for is kind of a bit different. So what we need to do here is that the question says that what two charges, right, which is this and this, are placed at the corners of the base of an equilateral triangle. So as we can see it like this, we can see that it is placed at the equilateral of a triangle, this point, right, and this point here, right. So it proceeds to say that the length of a side of the triangle is 0.7 meter, which means each side is 0.7 meter. The question asks us to find the electric field intensity at the apex of the triangle, which is this point right here. Now, we need to understand that from this diagram, the electric field due to this Q2, right, is extending this positive side to give us an electric field E2. Why for Q1 it is extending to give us electric field E1, but towards itself. If you look, Q2 is positive 1 microcoulomb. So its electric field will radiate outward. That's why it is radiating outward. But Q1 equals to negative 1 microcoulomb. Definitely, its electric field will go to radiating inwardly, right? As opposed to outwardly. So it will be radiating inwardly. So what we need to do here is that we need to solve for the electric field for E2 and likewise for E1 and add them together. You get the point? So we kind of find the resultant between both E1 and E2. So if we can find the resultant between E1 and E2, we can know the resultant, which is E, right? That it's being felt at the point P. So let's start solving. Firstly, we need to bring out the given, right? We can say that E1 is unknown, E2 is unknown, E is also unknown. But we know that Q1 equals negative 1 microcoulomb. Likewise, Q2 equals to 1 positive 1 microcoulomb, right? The distance between them is R equals to 0.7 meter. So I think this is all we need now. So what we need to do is that we need to say, okay, let's start with E2. E2 equals, to find the electric field, E2 equals K Q over what? R squared. And K is a constant with a value of 9 times 10 to the power of 9. Why Q? Now, you need to understand, as we explained in the previous examples, that electric field will only need the magnitude of the charge. We have nothing to do with the positive or negative sign. We'll find the magnitude, which is the absolute value. So in this case, as it is positive 1 microcoulomb, we'll just take it that way, right? That will be 1 times 10 to the power of negative 6. Divided by R here is 0.7 meter, right? But remember, we have to square it. So we can say that this equates to what? 9 times 10 to the power of 9 minus 6 divided by 0.49. After we simplify it, we end up having 9 times 10 to the power of 3 divided by 0.49. So this equates to 18.37, right, times 10 to the power of 3. So we can approximate this to be what? 18,400 Newton per coulomb, right? So we can see that the electric field E2 is equal to a value of 18,400 Newton per coulomb, right? The second thing we need to also say, but before then, we need to know the angle that E2 makes, right? The angle E2 makes with the electric field, the resultant electric field we are looking for. So let's go back and see the angle it makes. We can see that E2, which is this one here, right? This one here is making an angle of what? Alpha, because the triangle is this with an angle of 60 degree. If you extend it and form the same angle like that, definitely alpha have to be equal to what? 60 degree. So that simply means that the angle E2 makes, right? That means the electric field 2 with the E, which is the resultant that we are here to calculate for, is what? So we can say the theta or alpha equals 60 degree. So that's all we did for now for the E2. The next thing we need to calculate is E1. E1 is equal to K Q over R squared. Now, if we substitute the value of K, which is 9 times 10 to the power of 9, and Q1, now you know it's negative 1 microcoulomb, but we are not going to add the negatives. So we'll just get minus 6 divided by 0.7 squared. This will be the same thing as what? E2. Definitely E2 equals to E1, right? And equal to a value of 18,400 Newton per coulomb. So therefore, we've calculated for E2 and E1. So we need to calculate for the angle E1 makes with the resultant electric field. As we can see, here is E1, right? The angle E1 makes with the E-axis, so following from this side, then rotating, then back to this side, right? Will give us a value of 300, because alpha already consumed the 60-degree part of the what? Cycle. So the angle E1 makes with electric field resultant, which is this one, is what? 300 degree. So all we just need to do here is we substitute. We say that what? Alpha of 1. So let this be alpha of 1, of 2. So that one will be alpha of 1 to be equal to what? 300 degree. That's the angle for E1. So what we need to do, since we already know the value of each electric field component and the angle, now we need to find the what? Resultant. To find the resultant, right? So we say the summation of x component, right, of E1 and E2. That's what we're going to calculate now. So it can be calculated as saying the summation of E of x, right, is equal to E1 cosine of theta 1 plus E2 cosine of theta 2. So the theta here is same thing as the alpha we wrote. So we can say this equal to E1 and E2 are the same value. So we say 800 and 8400, right, times cosine. Theta 1 is same thing as what? Alpha 1, which is what? 300 degree. Likewise, E2 is the same as what? 800, 400, right? So it is 800, 400, then times the angle is what? Cosine, remember 60 degree for what? Alpha 2. So what we need to do here is to keep solving. So this equates to what? A value of 8400 times 0.5. If we find cos 300 is 0.5, likewise cos 60 is also what? 0.5. So at the end of the day, we end up having what? Still 8400 as what? The value, because 0.5 times this will become half of it, then half of 8400 plus another half of 800 give us a full 8400 Newton per coulomb. So the next thing we need to look for now is the what? Y component. So let's draw a line here. So summation of y component is equal to what? E1. Now it has to be sine theta 1 plus sine E2 E2 sine theta 2, right? This equals 8400 times sine of 300 plus 8400 times sine of 60 degree, right? So that equals the value of this 8400 times negative 0.866 plus 8400 times 0.866, which at the end of the day is going to give us 0 due to this negative sign at this point, right? So we can say that now, since we got the value of summation of f of x to be same as 18400 Newton per coulomb, and the summation for y equals 0, so we can say that the resultant, right, resultant E, right, equals the square root of summation of f of x, you square it, plus the summation of e of y, then you square it. So that will be equals to what? The square root of 18400 squared plus 0 squared, which is same as what? Square root of what? 18400 squared, right? So we know for sure this square cancel this square, right? Square root. So we end up having E to be equal to 18400 Newton per coulomb. So since we got the resultant electric field to be that, what is left is now the direction of the E field. The direction of the E, which is the resultant field, that can be calculated by saying tan of theta, or whatever you like to call it, the summation of E of y divided by summation of E of x. That gives us a value of 0 divided by 18400, which is also equal to 0 degree. So as we calculated previously, that shows that the angle is theta equals to 0 degree, which means it is directed along x axis, which is similar to what we used previously. So I hope the concept is clear. Try and make sure you look at the example on the force exerted, because it is quite similar. It's the same step, but now instead of looking for the force, we look for the electric field. And the only difference between electric field and the force is just the charge. Instead of having another charge, we have a point, virtual point P, whereby there is no charge there, but we just want to feel the force and the field there. That's just the essence, right? If there is any question about this topic, feel free to ask in the comment section. I'll be there to respond. Goodbye.